Hassler here. I just want to go ahead and give you some reminders for the multiple choice set number 6 on integration. And so I'm going to give you some integration rules, things that you need to know, and then I'm going to walk through the reverse chain rule process for you. And so as a reminder, if I were to integrate a polynomial function or a function with a rational exponent or a function with a negative exponent, remember that to integrate, I'm going to add 1 to the exponent and divide by the new exponent. And if there are no limits, I have to have this plus c. So plus c if no limits on the integral. Okay, if you do have limits on the integral, that's where you would then evaluate that integral. Okay. All right, and so if I were to integrate the e function, lucky for you, the antiderivative of e is e. If I were to integrate 1 over x dx, hey, that's the same as saying that I'm going to integrate x to the negative 1 dx. And that is the natural log of the absolute value of x plus c. And so it can be in either of those two forms. I know that when we typically have variables in the denominator, we like to rewrite so that that variable is in the numerator with a negative exponent, and then I can apply the rule that I gave you at first. But if that exponent is negative 1, my antiderivative is natural log. All right, let's review some trig. So if I integrate the cosine function, you get sine, right? Because the derivative of sine is cosine. If I integrate the sine function, I would get negative cosine. And if I integrate secant squared function, I would get tangent plus c, and plus c. So again, how I like to remember these is I like to say, well, what do I take the derivative of to get cosine? What do I take the derivative of to get sine? Well, if I take the derivative of cosine, I typically get a negative sine. And so if I integrate positive sine, I'm going to get a negative with the cosine. And what do I take the derivative of to get secant squared? I take the derivative of tangent. So remember, the integral is just the reverse of that derivative. Let's do the other one. So if I integrate secant x tangent x, that's equal to secant plus c. If I integrate cosecant x cotangent x, that's equal to negative cosecant x plus c. And if I integrate cotangent squared x dx, that's equal to negative cotangent plus c. And so remember, the items that have a co as the answer, okay, the items that have a co as the answer have a negative with that answer, right? Cosecant has a negative in the answer. Cotangent has a negative in the answer. Okay, so let me talk to you about the reverse chain rule. Here's really what the reverse chain rule looks like. The reverse chain rule looks like I have a function. We'll say f of g of x. So I have this composite function. And then I have this extra function with it. And I'll say that's g prime, okay? And so again, I'm going to qualify these for us. We have an outside function, and that's f of x. We have an inside function, that's g of x. Together, they make a composite function. So when I see a composite function, a function inside of another function, that signals to me that I need to be thinking about the reverse chain rule. And then we have this extra function. And that extra function is that g prime of x. That extra function is this right here. Okay? So when you go to integrate, what you need to do is that g prime of x or some form of it. I'm going to say that. meaning it could be like a 2g prime of x or a half g prime of x, right? You might be off by a factor. All right, so what you do is you integrate the outside function. So you're going to integrate f of x, and you want to keep that inside function inside. Okay? And then here's the next step that you need to remember. Then you divide by the derivative of the inside function. And when I divide by the derivative of that inside function, right, when I divide this by the derivative of that inside function, those two pieces go away. Okay? And so those two pieces are going to go away, which means I don't really have to deal with that extra function at all. That extra function is there because of the chain rule when taking the derivative. When I take the derivative using a chain rule, I multiply by the derivative of the inside. So when I go to integrate, I have that extra piece already attached. So I'm going to divide by the derivative of the inside to get rid of that extra piece. Okay, so your job is to work to the best of your ability through this problem set, check the answer key, and then be ready to ask me questions.